Hey there guys, in this video we're going to be solving a quite nice radical equation where we have x times the square root of x equals x plus the square root of x. And obviously we want to solve for x values, but before we do that, hit the subscribe button for more awesome videos. So first of all, notice that x is under the square root, which means that x must be something non-negative. And this is the only condition that we have for our equation. And secondly, notice that x equals the square root of x times the square root of x, which means that our equation is equivalent to this equation. X times the square root of x equals the square root of x times the square root of x plus the square root of x. Now, obviously, I can go ahead and factor out the square root of x on the right-hand side. So I'm going to have x times the square root of x equals the square root of x times the quantity root x plus 1. Next, let's go ahead and move the expression on the right-hand side to the left-hand side to have everything on the same side. So we're going to have x times the square root of x minus the square root of x times the square root of x plus 1 equals 0. Now, obviously, the square root of x is our common factor on the left-hand side, so we can pull it out. And if you do so, we're going to have root x times the quantity x minus the quantity root x plus 1 equals 0. Now, notice that we have a product, and the product is equal to 0. So based on the zero product property, we're going to have two cases. In the first case, we're going to have root x equals 0, which means that x equals 0. And remember that x must have been greater than or equal to 0, and 0 is greater than or equal to 0, which means that this is a valid solution. And in the second case, we're going to have x minus the quantity root x plus 1 equals 0. So the left-hand side is x minus root x minus 1. So I'm going to go ahead and move the square root to the right-hand side to isolate it. So I'm going to have x minus 1 equals the square root of x. And now, notice that the right-hand side is non-negative. Therefore, the left-hand side must be non-negative as well. So I can go ahead and say that x minus 1 is non-negative, which means that x is greater than or equal to 1. So this is our second condition for our second case, and we need to keep that in mind. Next, let's go ahead and square both sides to get rid of the radical. So we're going to have x squared minus 2x plus 1 equals x. And then if we move the x to the left-hand side, we're going to have a simple quadratic equation. We're going to have x squared minus 3x plus 1 equals 0. Next, let's go ahead and use the quadratic formula to solve for x. So we're going to have x equals 3 plus or minus the square root of 9 minus 4 times 1 times 1, all divided by 2. Which means that x equals 3 plus or minus the square root of 5, all divided by 2. But notice that x must be greater than or equal to 1. So let's go ahead and see if these values are greater than or equal to 1. So let's say that x equals 3 plus root 5, all divided by 2. So this is approximately equal to 3 plus 2.2, all divided by 2, which means that it is equal to 5.2 divided by 2, which is equal to 2.6. And 2.6 is greater than 1, therefore this is a valid solution. But if x equals 3 minus square root of 5 divided by 2, this is going to approximately equal to 3 minus 2.2 divided by 2, which equals 0.8 divided by 2, which equals 0.4. And 0.4 is not greater than 1. Therefore, this is not a valid solution. So we found two solutions for our equation. This one and this one. Great. So this brings us to the end of this video. Thank you for watching this. Please consider subscribing for more contents like this and hit the like button, and I'll see you later.